Hello everyone, this is Mohammad Asim Amin. I'm from University of Genova and this project is a collaboration between University of Genova and University of Nice. And the title of this paper is the cost optimization incorporating the photovoltaic power forecast using neural networks in an energy management system. For this paper, we have utilized the receding horizon method to design to integrate the updated photovoltaic power generation in an effective way. And at the second level, we have developed a three neural net RNN-based forecasting algorithm that compares a different architecture and evaluate their uh, uh, the forecasting error, and then most accurate one are utilized for the EMS level. Secondly, the best performing algorithm fit into the EMS photovoltaic power production data, and then this process compares different approaches. In the first one, PV forecasts are updated every hour, and the EMS is run to optimize dispatch decisions for upcoming 23 hours. In the second method, the PV forecast is received at the midnight, and the EMS optimize the decision. Then the proposed joint approach is verified using an accurate EMS and by comparing the results with the real PV powered data benchmark. And the results indicate that dispatching of the units can be accurately predicted using the proposed forecasting technique and with an overly updated approach yielding the most precise outcomes. Based on the literature review, renewable energy and the PV integration in the power system require an accurate forecasting approaches or algorithms, and the inherent intermittent nature of the PV power cause hurdles to broad adoption and the claims for the PV forecasting to stable and reliable economic dispatch. However, the integration of the PV inside the microgrid causes stochastic behavior that require management in the real-time operation. In renewable energy forecast, there exists a short-term, medium-term forecast range from few seconds to hour, and the long-term forecast refers to days, months, and several years. In the real-time operation, the short and medium-term forecasts are utilized for the economic dispatch, unit commitment problem, and the scheduling of the different resources. The contribution of this paper is to develop of the precise algorithm to perform hourly and day-ahead forecasts based on the available data from the open repositories, and then fine-tune the PV production forecasting output with a low computational power by sliding over an hourly time and scale and bypassing the need for the complex updates. The feed-in PV forecast in the efficient EMS to manage the economic dispatch decisions for short and long-term constraints and minimize the overall cost. Initially, a flexible and accurate forecasting algorithm is developed over the dataset retrieved from 81 kilowatt of power plant from the Savona campus of University of Genoa. And secondly, this data are fed into the mixed and linear programming based EMS system developed particularly the microgrid for the Savona campus, University of Genova, and dispatch the decision to minimize the operational cost. So the framework is basically a two-stage. In the first stage, we have extraction of the data, then converting into the STL decomposition, then implementing machine learning algorithms and validation, and then test of the model, and then further this full forecasting algorithm has the comparison between different algorithms. In the second level, this forecasting is fed into the EMS system where we have combined heat power system, batteries, boilers, electric loads, and the thermal loads, and there exists the power exchange between the power grid and the local loads in the islanded microgrid. And this, in the first logic is like the hourly update. The second logic is an update of the forecast every midnight, and then EMS dispatch the decision for the remaining hours. There are like three methods for the forecasting. The first is an LSTM, one of the standard one, then the deep LSTM, and then bidirectional LSTM with attenuation. So these are the mathematical model that we have used, which is quite standard. And then further, they're like for the EMS system, the mathematical model for the primary and electrical thermal powers for the programmable unit is approximated by using the piecewise linear function. In addition, the startup and shutdown cost, on and off states, power production constraints, power adjustments mode, incentives with the CHP units, carbon emissions, and maintenance costs are included. Regarding the energy system model, the power exchange with the electrical network proportional to the energy storage are the SOC, the limits related to the power charging, discharging, and limit associations with the battery cycle and life along with the degradation cost. And for the flexible loads can be added to implement the demand response strategy. The related mathematical design expresses in the reference given. For the power balance equation, it can be calculated from this equation on the top left corner. Probably, yeah, it's a balance of the energy with the purchased and sold, the electrical loads, then connected thermal loads, the renewable energy resources, and so on and so forth. And further, the final cost is minimized by the EMS system, which is the sum of the power exchange with the electrical network, and then further on, the thermal network balance is given, and then the cost associated with the thermal network is as follows, and the overall final cost is to minimize the energy management system. The update logic for the is like the first is like the renewable energy production is inputted into the EMS following the receding horizon approach to compute the optimal decisions. In the first method, which we calculated as a FC1, use the LSTM RNN model to predict the PV power for the next 23 hours at each time steps, providing update forecast to the EMS, and then associated cost for the FC1 is calculated as, and then FC2 is like introduced, which generates the PV production forecast at the midnight for the following 23 hours, and feeding only the initial forecast in the EMS system. And to for the FC2, like the day starts from the first and then total number of the days. The overall cost for the second approach is given as follows: CFC2 total, which is yeah. And further on, to establish the benchmark for comparing the FC1 and FC2, the variable P real renewable energy resources introduces, which denotes the actual recorded power output from the renewable energy, and then cost is labeled as a serial. The procedure is designed as BFC for the clearance so that we can follow in the presentation to allow the comparison between the method and the benchmark. The difference between the cost generated by the EMS using the real power production and also the one derived from the FC1 procedures is computed as follows: the difference between the real and the method which we have proposed, and similarly the relative error between the first method and their actual. And then we could also compute the similarly for the FC2. For this study, the very to effectiveness of the forecasting tool is like we have the original data set, which is constructed of the 6 years of the data, which is retrieved from the 81 kilowatt of power plant in Savannah campus. And then we have utilized the some open repository from the European Union with the 5 minute of resolution of and also the special resolution of the 5 kilometer and with a 1 hour of data. It is important to note that the data can be downloaded from as a 1 year, and the final matrix has a dimension of 8760 cross 3 for all the years. Data obtained from the PVGIS includes the solar highest temperature at 2 meter above sea level and wind speed at 10 meter above sea level. The PV data is resampled to the hourly format to align with the hourly weather data as noted in the previous studies. And using the STL decomposition method, this method is variable is like the seasonal trend, decomposition, and residual component are combined into the single data set, and it represented as a DD. So the LSTM is a single layer model. Deep LSTM has a 5 layer, and bidirectional LSTM has like the 5 layer incorporates two dropout layer and feature of a single temporal attenuation. And we have run the training over a different batch size, different episodes, different learning days to find the best combination. And then training and testing sets for the RNN are created with the 80% for the training, 20% for the testing, and respectively. You can see here the data set utilized for this model. OD is basically the one which we have extracted. And then we have the DD, which basically is a decomposed data set, which consists of the STL decomposition of the OD. And then we have compared different algorithms like the LSTM, LSTM, bidirectional LSTM, and their associated errors are compared as follows. And then we have the Pearson correlation matrix, which is the comparison of the different their comparison between the different variables, or you can say the data points. And we can see like there is a high association with the different like the height of the sun, and the most association is with the PV power basically, and also the solar irradiance. And by comparing, so when we go with the results, the microgrid is composed of like two CHP plants with the consisting of the 65 kilowatt of electric load capacity and 112 of kilowatt of thermal capacity, which fed by the natural gas. And on the other hand, the energy storage, the capacity of for 1 kilowatt and electrical thermal load of each, and the one PV plant with 81 kilowatt of capacity, and the two boilers 51 kilowatt. The process runs each month, and here is the results for the proposed method. We have the electrical thermal load request August in 2023 and the real data for each month in 2023, and then we have compared different results that you see, like the comparison between the FC1 and FC2, and it can be seen that the mean absolute error is below 2 kilowatt, under 2.5%, and FC1 performs better than FC2, likely due to the more immediate influence of the recent meteorological condition on the next hour forecast. And the comparison between the FC1 and FC2 is can be seen as in the picture. So the overall study, the comparison of the cost difference with respect to the benchmark over the first week of August, can be seen here. The difference, like, is the delta C1, delta C2 that we have discussed before, and FC1 logic, FC1, FC2 logic fed into EMS to calculate the economic dispatch and unit commitment problem, and accurate PV forecast through the deep reinforced through the RNN LSTM algorithm that enables the SCEMS to compute the production unit, energy storage, and set point for the electrical and thermal loads. FC1 outperforms the FC2. The comparison with the benchmark justify their effectiveness that can be seen, and the conclusion is that we have developed a robust algorithm for the forecasting of PV generation using the publicly available data for the near real-time application. The focus was to achieve the optimal dispatch of the system unit by utilizing the proposed algorithms, and we have trained 6 years of the data, 81 kilowatt power plant, comparing different architecture to get a more effective forecast. Then further, these approaches were tested over the first week of the month in 2023, and one that updates the forecast hourly, and the another is to provide the daily updates. And the results indicate that mean absolute error is below 2.5% of the PV production forecasts that are 5-layer LSTM RNN, which performs better. And then economically, regarding the economic dispatch, computes the EMS, the hourly forecast update to be fed to the EMS results, which 6% of cost reduction. And future research will likely focus on refining the forecast model, enhancing day ahead prediction, and incorporating additional meteorological features to improve the output estimation. Additionally, there will be the efforts to develop the reliable model for predicting the electrical and thermal load demand without relying on the previous forecast correction. Thank you so much. This project is funded by the Chloe Marie Curie at University of Genova, University of Nice collaboration. Thank you so much. If you have any question, please ask.